Leaving the best to the last, please welcome Julian Lau, Head of Solutions Architect ASEAN, Worldwide Public Sector, AWS.
Good afternoon. So my section is talking about deep dive, Amazon Relational Database Services. Before I started, let me ask you a couple of questions. How many of you actually used the RDS services before? Quite a few. How many of you is actually coming from the DBA background? Some. So in my section, I will talk a lot more about the RDS services and also some internal implementation why the RDS services is actually quite good to our customer in terms of the performance, scalability, availability, and also security. If some of you haven't used the RDS services before, you will be able to know a bit more about the details. For those of you already using our services, you can even understand a bit more about our internal implementation, why the scalability and also the performance is really good to our customer. So for the database services, to be honest, it's not something new. For Amazon Web Services, we actually provide a lot of different database services to our customer. That will include the relational databases, including the Aurora, and also the relational database services. For relational database services, we actually provide different class of the database to the customer. For example, that can be MySQL, Postgres, MariaDB, Oracle, and SQL Server. We also support some non-relational database services. For example, the Amazon DynamoDB, which is a NoSQL database. And we also support the Amazon Elastic Cache, which is the Redis or Memcached implementation from us. We also support the Amazon LabTune, which is a graph database for our customer. Basically, these are all the database implementation from Amazon Web Services. For some of you already running the database services on premises, you may be also interested in how you are able to move your database to the cloud, in which we have a services called AWS Database Migration Services, which will help you to collect the data, replicate to the database running on our platform. We support the full synchronization and also capture the delta change such a way that you are able to migrate your database in progress. Now, let's move on to talk about the relational databases. In the past, the relational databases is actually very complex and very complicated. In terms of managing the whole database, you need to install it. You need to ensure your database is actually up to date. Your operating system is actually up to date. You also need to ensure the security. Sometimes the job for the system administrator or the DBA is quite tough. And that is the reason why we actually implement a managed database services for our customer, RDS. We want to provide a lower TCO to our customer and also provide some high availability and disaster recovery across multiple data center capability to our customer. So what is so special about the Amazon RDS? Basically, there are a few things. Number one, easy to administer. Number two, available and durable. Number three, highly scalable. And also, that is a fast and secure database for our customer. Let's talk about ease of administration. In the past, when you set up the database, you may need to do a lot of tasks, right? In terms of setting up the OS, do the OS hardening, and then set up your database, do the necessary configuration, ongoing performance tuning, all this kind of thing. Now, with our RDS services, basically, you can use just one single management console. Then you are able to set up the database in short period of time. MultiAC deployment. Customer really likes our design for the multiple availability zone within a region, such a way that when you build your HA system, you are actually building a HA system in cross data center scenario. And our RDS out of the box already support this kind of multi-AC. That means you are able to set up a HA database across multiple data center. So let's say, for example, if your database, one of the database node goes down, we are able to fail over to another node on another data center. If the whole data center goes down, we are also able to fail over to another database running on another data center. So that's why I said that is a data center level of HA for a customer. Read replicas. A lot of transactional applications actually have a lot of performance issue. So what people trying to solve and how they are able to solve is actually make use of the read replicas to offload the read to the read-only replicas. So this is out of the box on the RDS setup. You are able to set up the read replica for MySQL, Postgres, and all different databases out of the box just with few clicks in our management console. Automated backup. So data is actually very, very important for us. So I believe every single DBA here, one of your day-to-day job is actually make sure you remember to do the backup. You may write some script to automate the backup by yourself, or you make use of some of the backup software to back up your database regularly. If you are using the RDS, all these different kind of things is actually already automated. What you need to do is just come to our management console, telling us what is your retention period. And then we will help you to do the backup in every day, okay? Database snapshot. Whenever we talk about backup, sometimes people talk about full backup or take a snapshot. Out of the box in RDS is actually we support the snapshot such a way that whenever we do the backup, we actually only take the difference on daily basis, for example. And then this is actually greatly reduce the amount of storage you need to have to store the backup. So this is also one of the good features. Some of the customers really like RDS. Scalability. Traditionally, when you want to set up a scalable infrastructure for the web tier, it's actually quite easy to do so, especially if you are running your infrastructure on Amazon Web Services. We have the auto-scale capability, such a way that when you have lot of demand for web server farm, we are able to scale out your infrastructure automatically. And when the demands goes down, we are also able to help you scale in your infrastructure such a way that the amount of money you pay for the infrastructure can be greatly reduced, just a little bit more than what you need to entertain the incoming demand. For the databases, in the past, if you set up your database on premises, the scalability is not that easy to do so. But with RDS, the scalability is actually out of the box. We allow you to scale your compute for the RDS, either scale up or scale down on demand, such a way that, if you see not more demand coming into your application, you are able to come to our management console, say that you want a more powerful databases, then we are able to change the configuration on the fly. And the storage, that is another key headache for some of the DBA. Think about the purpose of the database. You need to store the data into the databases. And the storage itself, you need to dictate the amount of storage initially when you set up the databases. But if you are using the RDS, the storage is actually can be scaled on demand. Let's say, for example, tomorrow, you may only running 100 GB of data. Then you create like 150 GB of volume. The next day, you realize that all of a sudden, your database storage growing so fast, you find that 150 GB is not enough. What you need to do, you come to our management console saying that you want more data. Maybe like you change to 300 GB, then click a button. Then we are able to scale the storage on demand also. The scalability here is good, but we're still not able to automate the scalability of the compute of the RDS instance. For example, as I mentioned, if you want to have a more powerful databases, you need to come to a management console and change the configuration by yourself. What happens if Amazon Web Services are able to provide the auto-scaling on the database itself? I will share with you a little bit more new feature from RDS in the later stage. Let's deep dive into the Aurora. As I mentioned, on our database offering, we actually provide different database services for our customer. One of the cool services is actually what we call the Amazon Aurora. So what's all about the Aurora? Aurora database is actually our implementation for MySQL and PostgreSQL. Basically, what we did is actually we grabbed the source code from MySQL and also PostgreSQL, and then fine-tune that such a way that fully utilize the Amazon Web Services infrastructure architecture, and then provide a better database services to our customer. And the good thing here is, after we change the code, fully optimized running on our platform, we're still able to fully compatible with the vanilla version of the MySQL or the PostgreSQL database. But what's the benefit here when after we change the code fully optimized is actually a few things. Number one, that is a scale out distributed the way that the scalability is out of the box. That is a service-oriented architecture. Will give you a lot more detail about the internal implementation of the architecture about the RDS database in the later stage. Fully managed services, you don't need to manage a lot of things by yourself. You don't need to manage the security and all that. So what is all about the Aurora database? The Aurora database is actually, again, we grab the source code from MySQL and PostgreSQL, and then we change the implementation such a way that will optimize for the Amazon Web Services cloud infrastructure. You can see that from the diagram. When we set up our architecture for the Aurora, it's actually split into multiple nodes, master and also some of the replica. And the key thing here is we split the whole processing for the database engine into two parts. One is the usual transaction processing engine. Let's say, for example, you run a SQL statement, insert, update, delete, then the MySQL engine will be responsible for processing the statement. And then another part into what we call the storage engine. We basically turn the I/O, the database I/O, and pass it into another layer of processing engine to do so. Why we want to do that? It's really because we are able to make use of this architecture to optimize the performance for the MySQL or the database. Another key function or features here is really about the storage engine, how we store our data files. You know, we have the multiple availability zone architecture. As I mentioned earlier, the multiple availability zone is actually very, very important for our customers, such a way that you can build a HA system across multiple data centers. Now, when we build our storage engine, we actually leverage more than 2 availability zones. It's actually 3 availability zones, such a way that your scalability and also availability is actually across at least 3 data centers. And then with this kind of architecture, with the storage engine implementation in terms of the replication, the performance can further enhance, in which we split the I/O into multiple copies. In total, to be honest, we have 3 availability zones, and in the actual storage, we have 6 copies of your data for one single database. So, again, what is the benefit for running the Aurora database? It's actually automate a lot of administrative tasks. For example, again, you only need to focus on your role as a DBA. You focus on schema design, query construction, query optimization. But you just offload all the tedious job to Amazon Web Services, and we are here to help you to automate the whole things, including the automated failover, backup recovery, setup, push button scaling, automated patching, etc., etc. The key performance gain here, as I mentioned, we grab the source code, and then we optimize for the Amazon Web Services infrastructure architecture. What is the outcome? Here's the outcome. Number one, we are able to get maximum of 5x performance gain against the vanilla version of the MySQL databases, 5x. And also, when we say that we are able to achieve maximum of 5x performance, it's not just about a performance boost. We are also able to scale the performance depending on your situation. If you are the DBA, you will know that the scalability of the database sometimes is so hard to do so. In terms of maybe you are talking about the scalability with the total number of user connections. Or you are talking about the scalability about the total number of tables within one single database. Or you are talking about the database size for one single database. But you can see that from the table, no matter which scalability situation you are talking about, we are always able to achieve a really, really good performance against the vanilla version of the MySQL implementation. Let's say, for example, for the user connection, we are able to achieve up to 8 times faster than the vanilla version of the MySQL. Or in terms of the number of tables, we are able to achieve more than 11 times better performance than the vanilla version of the MySQL. Or with the database size, depending on the benchmarking tools you are talking about. If that is Sysbench, we are up to 21 times faster. Or if you are talking about TPCC, we are actually more than 136 times faster than the vanilla version of the MySQL. So the performance here is really, really good for our customer. Why? Why we are able to do that? Yes, a lot of people know that we have a really good infrastructure from Amazon Web Services. We have the MultiAC, we have the region concept, we have a really good storage system called the Elastic Block Storage, EBS. But why all of a sudden, after Amazon Web Services getting the source code, make a little bit changes, put it back into the infrastructure, we are able to do such a dramatic performance gain for the implementation? There are a few reasons behind. Number one, we do less work. In terms of what? In terms of fewer IOs and also minimize the network packet. Traditionally, when you run a database system, if you want to do a I/O system for the database, the I/O and the core processing for the database is actually quite chatty. You will need to do a lot of I/O to save the record, save the data page before you are able to commit the transaction. We use some algorithms to optimize that such a way that we are able to minimize the number of I/O required. Or from the network packet transfer perspective, when you set up a cluster, you want to replicate the data from the primary node to the secondary node. That will be also quite chatty if you are setting up a synchronized commit types of replication. We are also make use of some optimization technology and algorithms such a way that we are also able to minimize the network packet. On the other hand, we are able to make the whole stuff more efficient. Reason why is because, just like what I mentioned, we basically split the processing engine and the storage engine into 2 different tiers. We further split up the tasks required into different tiers such a way that we make it more efficient. So remember, after we do this, the database is actually all about the I/O, all about the network attached storage performance, and also the high throughput processing is all about context switch. By making these kind of changes, we are able to achieve the performance I have just mentioned to you. Now let's do a next level of the comparison for the algorithms I have mentioned to you in terms of minimize the I/O, minimize the network packet required. Why we are able to do that? On the left-hand side is actually a traditional MySQL setup with the replica on our platform. Basically, you can see that we will have a primary instance on AC1. And then on the other hand, we have the replica instance on AC2. Basically, if you set up this kind of database replication, you will need to deal with different types of operation between 2 instances, number one. Number two, between the instance and also the storage system, which is the elastic block storage, you also need to deal with different kind of operation. That will include the green light, the yellow light, the pink light, the blue light, and the purple light, which is the log, the binary log, the data, the double write, which is write ahead log, and also the metadata, which is the frame files. So you can see that on the left-hand side, because of the MySQL vanilla version of the MySQL implementation, that needs to coordinate between the storage systems and the communication between the primary instance and the replica instance. You can see that we are very chatty. in terms of all the operation always needs to go through the storage system, primary node, secondary node, and then to the storage system on the other side. Now, let's move on to talk about how Aurora to deal with all this kind of operation, which is on the right-hand side. You can see that we mainly leverage the redo log for the communication. The green line is actually the redo log. If you are the database expert, you will know that every time when the database trying to save the record, it's actually saved to the redo log first. And then there's a processing to make those redo log to make the write against the data page right to the database. So in the past, it's actually quite complicated. But now, we are actually using the redo log only for what we call the log structured data storage, in which whenever we want to communicate between the log, we just replicate the redo log, which is only the transaction replication across multiple nodes, number one. Number two, as I mentioned, we actually split the processing engine and also the storage engine into two different tiers. You can see that on the 3 nodes on the above is actually one tier of the processing. And then on the second tier, which is the field storage node you see in the diagram, is actually the second tier. We have some compute to do the redo log application onto the storage engine. Now, you can see that when we do that, we actually greatly reduce the amount of traffics and also communication between all the different nodes, even though we need to do the communication across 3 nodes with 8 availability zone compared to the 2 nodes on the left-hand side. And on the other hand, for the storage system, we also greatly reduce the amount of communication across the multiple nodes in different availability zone. The only key part here is actually, this diagram didn't mention, the only key part here is why we are able to only replicate the redo log instead of everything to all the different players in the diagram is really because of on the processing layer, we have, on the storage layer, we actually have some processing engine to process the redo log before we save into the databases. Basically, what we do is actually in the past, for the traditional database system, we rely on the storage, on the data page, on the storage engine to do the query. That is actually quite I/O intensive. But right now, we actually leverage the redo log directly instead of rely on the redo log right to the data page, which is a 2-step approach to become a 1-step approach. We greatly improve the performance here. Okay, we talk a lot about the performance. What about the availability? A lot of people, when they run the system on our platform, basically it's actually mission critical. Cloud is actually the new normal. A lot of people running the mission critical system onto our platform. And the database is actually one of the key components that needs to be highly available for the application, such a way that you provide the best SLA to your customer, the best uptime to your customer. So how we are able to do that? Again, because the way we design the Aurora is actually fully utilize the 3 availability zone, storing 6 copies of the data. And then you can see that on the left-hand side, if you are talking about the read-write availability, if the whole data center goes down, your database is still up and running and also able to accept the read query or the write query. If you are talking about the read availability, we also support even more higher standard for the SLA to the customer, in which, let's say, for example, we have 6 copies of data across 3 availability zones. You can see that in the diagram, worst case scenario, if 3 copies of the data already gone, we're still able to support the read operation for our customer. So that's why, on top of the performance gain with the Aurora databases, the availability for running the databases is actually better than the usual way to set up the database on the cloud or on the on-premises. Then what about the read replica? Read replica is really good because you are able to offload some of the query to the read replica, such a way that the master node only focus on the write operation. Right now, with the Aurora database, we actually support up to 15 read replica. 15 read replica. And then across all these 15 read replica, you are able to promote any replica to become the master node anytime you want. So we have 15 read replica. What's so special? I need to talk to each of the individual read replica. I also need to determine which read replica is actually up and running before I am able to issue the query. So that's why we actually introduced a new feature called reader endpoint with load balancing and auto scaling, such a way that from your database application point of view, you only need to using one connection string. And then when the connection comes to our platform, we actually have an auto-scaling layer to scale out the read replica, or based on the availability of the read replica to redirect the request to the corresponding read replica to handle the read request. So from your perspective, from the application perspective, it's actually greatly reduced the complexity in terms of writing your program code. What about the ease of use? So again, the RDS database already help our customer to solve a lot of problems and minimize the overhead for the day-to-day operation. Here is the diagram to show you how we are able to minimize the operation. On the left-hand side, you can see that all the stuff you need to do by yourself. If you set up the database onto our platform by yourself or set up on-premises, you need to do the app optimization, scaling, taking care of the availability, backup, OS patching, installation, and all things. If you're talking about the database setting up on the EC2, which is our virtual machine platform, basically some of the OS installation, server maintenance, rack and stat, and power, and all that already taken care by the Amazon Web Services. Now, if you're talking about the RDS databases, what's so special about this is we actually help you to do more, which is we're taking care of the scaling, availability, database backup, software patching, etc. And you only required to do the app optimization as the DBA. For example, you may have you design some query, and then you find that some of the index is not correct. You may need to do some index and tuning on the database. You still need to do it. But from the database perspective, a lot of things you don't need to do that anymore. What about the storage? Again, the storage system for the RDS database is actually can be auto-scale up to 64 terabytes. There's no performance impact. You don't need to shut down your database before you add more data to your databases. This is a really good setup in terms of when you want to change the configuration, you just change it, and then we will apply the changes on the fly without affecting the database performance. And we will also do the continuous incremental backup to the Amazon S3 and also do the create the user snapshot and all that. All these kind of operation will not have any performance impact to your database cluster. With the Aurora database, we also include some advanced feature which is not very common if you run an on-premises database. That includes the fast database cloning. Remember, as I mentioned, we actually split the processing engine and the storage engine into two different tiers. And then we also make use of the EBS snapshot to help our customer to replicate the data. So let's say, for example, if you all of a sudden want to make a database clone to another instance for whatever reason, maybe for testing or whatever, you can do it very quickly in our management console. You just have a few clicks, then we were able to replicate and clone a database onto a new instance in a short period of time. What about the security and monitoring? Whenever people talk about the security, people talk about a few things. Secure data at rest, number one. Secure data in process, number two. Number three, secure data in transit. So RDS or the Aurora databases actually able to take care of all these kind of requirements. For example, from the network perspective, we are able to allow you to launch your database into your own VPC, such a way that everything can be private. You don't necessarily need to put an internet gateway inside the VPC. You can still able to access your databases. And if you set up the database this way without the internet connection, what is mean by that? No one from the internet are able to access your database. This is a really, really secure setup for our customer. For the RDS, we fully integrate with the IAM based on the resource level permission control. If you are the guys responsible for the database security, you will love this feature. Secure data at rest. RDS, for all the RDS databases, we support the secure data at rest, in which we have something called the checkbox types of encryption. You come to our management console, say that you want to encrypt the database, take a checkbox, then we are able to encrypt the databases automatically. Of course, the key is actually leverage our key management services, KMS, to store the key. And we also support cross-region replication, Snapshot, etc., such a way that when you deploy the database, if your expectation of the security is really high, all of the stuff is actually out of the box. What about the database activity monitoring? A lot of customers asking for the DAM. For the RDS Aurora, we also support the DAM feature for our customer, in which we are able to ship all the log to the CloudWatch, and then CloudWatch will forward all the log to the S3, and you are able to make use of the Athena or the QuickSight to do the necessary analysis for all the database activity inside your database. All this kind of thing is actually available to our customer today. But in the past 6 months, we actually introduced not more exciting feature to our customer, which I wanted to share with you today. So first of all, about the MySQL compatibility. In the past, we support the MySQL 5.6 versions. Now we also introduce a MySQL 5.7 compatibility, in which some advanced features is already there. For example, the JSON support, generated column, spatial index, all these kind of things. In which if you wanted to run the MySQL 5.7, you are able to make use of the Aurora to do so immediately and without any compatibility problem, number one. And number two, you are able to enjoy the performance gain immediately. Number two, remember the way I mentioned to you, the way we set up the storage system is actually make use of the redo log. So that's why we introduced a new feature called Backtrack. So what is all about Backtrack? If you are the DBA, what is the most hectic things you encounter from your day-to-day job? An end user come to you may say that, oh, I accidentally drop a table, or I run a query, delete something into the database. So in those kind of situations, what you need to do, you need to restore from the backup. If you are lucky, you do the daily backup, you are able to restore the backup from the midnight yesterday, but you will have some data loss, right? So Backtrack is actually a feature allows you to go back to any time you want in the past. So what you need to do is actually enable this feature in the RDS database and then set that how long you want to enable the Backtrack, for example, 24 hours. Once you enable that, what kind of thing you wanted to do? For example, at 9 o'clock, I accidentally delete a table. Then what you can do is actually you go to our RDS database, say that I want to go back, database go back to the point that is 5:59. You are able to do that up to down to the minute interval. So that's why this feature is really good for our customer. First of all, you mentioned about the interval, how long you want to enable the Backtrack from an hour to 72 hours. The second feature is once you enable the features, you are able to backtrack to any point of time you want. Very, very convenient for the feature for our customer. This is the super cool thing for our customer. Remember I mentioned to you about the scalability of the database. Our RDS database is actually able to scale up and down. You just come to a management console, change the configuration. For example, in the past, you may running 2 CPU, 60 GB of memory. Then you find that that is not enough. What you can do is actually you change to a more powerful configuration. For example, 4 CPU, 32 GB of memory, click a button. Then we will scale up your database. This is what we call the push button scalability. Cool feature, but not cool enough from my perspective. Why we don't do something that is the whole scaling is actually automated? This is something we introduced 2 months ago, what we call the Aurora serverless. So what is Aurora serverless? Basically, you don't need to define what is the the number of CPU or memory you wanted to run your database. You only need to mention about the minimum configuration in terms of the CPU and memory, and the maximum number of CPU and memory you wanted to run. And then in the real time, we are able to, based on the demand, to scale up your database in terms of the CPU and memory, or scale down the CPU and memory based on the actual demand. This is a really good feature. On one hand, we are able to perform better when the incoming demand all of a sudden boosts to a really high value. And at the same time, we are also able to help our customer to save the cost running a database, because we are able to, based on the actual demand, to scale down back to the more optimal configurations. Performance Insight, we actually have new features to show more details about the performance characteristics of your database on our platform called the Performance Insight. And before I end, I show you a quick demo on the RDS database, because the serverless database is actually very useful. So that's why I would like to give you a demo on this part of feature. So this is our management console. I'm sure you're all familiar with this user interface. And then I choose the RDS. So I can click on the Create Database. I select the Aurora. You can see that I'm also able to select some other databases. But now, because of I want to show the serverless Aurora, I select the Aurora. And you're also able to see that we have different compatibility, MySQL 5.6, 5.7, and also the PostgreSQL. Now, here's come to the most important part. In the past, you are able to specify the instance type for your database, RDS database, in terms of the CPU and memory. For example, if I choose the R4.X large, I'm able to get 4 CPU and 30 GB of memory. Here is the new option called serverless. I don't need to mention about the instance type anymore. I type in the database identifier, the username, the password. Then I click Next. Now, here is the most important configuration. You can see that we have a new option here called the capacity settings, such a way that you are able to specify the minimum Aurora capacity unit. For example, from 2, which is 4 GB of memory, till the 256 GB of memory. And we are able to scale the CPU on demand also. So again, the serverless, once I click the Create Database, we are able to provision the cluster automatically. And the resources provision is actually based on the actual demand, the incoming actual demand to the databases. We are able to scale from 4 GB of memory to 256 GB, and also, of course, together with the associated CPU required. So that's all the presentation and demo I wanted to share with you today. So I hope you enjoy everything I share with you. One of the call to action is go back, try the new things by yourself. Thank you very much.
Thank you, everyone. Please join us for the networking.